So in the previous tutorial, actually we have set up this ABP layered blend, which is a separate anim instance. And now let's see how we can plug this to our ABP locomotion anim instance and how we can actually override the forward facing anims. Right. So, so since we are going to actually override the forward facing starts, we can go to the anim graph locomotion and the start state, and here is the place actually I'm getting the initial start anim, right? So based on the rotation mode, so if it is strafing, I will simply take the start cardinals, but if it is forward facing, then based on the forward facing starts, I select it and return it as the anim sequence. So the similar thing actually we have to done for the animation overrides as well, but it should be run in a different sequence evaluator. So first what we can do is we can actually first start by linking this anim instance to this specific anim instance. So the way to do that is basically there is a node called should be linked anim graph. Yeah, and here we have to specify what's our instance class. In my case, our instance class is ABP layered blend. So soon after I added this instance class, it automatically added the input pins. Actually, these input pins are the ones that we specified here, right? So we have base pos as the input pos and blend pos as the input pos. So they will be appeared at here. So as the base pos, we can provide the existing pos, and as the blend pos, I have to give whatever the overridable animation or overriding animations that I'm been providing at here. So for that, let's use a different sequence evaluator, and there yeah, here basically the sequence can be dynamic and it can be looped. It can be teleport to explicit time, and I think I don't need to actually expose this explicit time as a pin. Instead, I will simply make it as a dynamic value, and I will disable the expose as pin. Right, and then I can use its output as the blend pos, but obviously we need to actually set up some on update functions at here, but let's do that later on. For now, let's plug this to blend pos. Okay, and then I need to expose these four variables that I've been mentioned as, or that I've been categorized as setup. So first one is weight, so let's expose it as pin. The second one should be interp speed, expose as pin. The third one should be blend time, so I'll reorganize like this, and let's expose as a pin, and finally blend type. Blend type and blend type. Okay, those are the four. And then we have this anim override start forward facing. So let's break it. Oh, yeah. If you do like that, actually, we have to have a separate function to do the filterings to select actually whatever the forward facing anim that we are going to use. So instead of that, let's delete it from here and maybe let's go to setup start state. Yeah. So here, what I can do is uh, I can get the start overrides. So maybe let's create a function for that. So we have this anim set functions to get start anim. Similarly, let's create a new function to call get start anim overrides. Send it to here. It should be a pure function and thread safe. And then let's use the property access pin and let's check whether it's forward facing or not. So easiest way is simply check the B orient rotation to movement. B orient rotation to movement. So if this one is true, then we are forward facing, otherwise strafing. So if we are forward facing, I can get the existing stuff from here and let's break it, and then let's expand it further, and finally I should be able to return one of these anim sequence overrides. So I'll add the return pin as well, and as the output let's return a value which is the type of anim override. It's anim override sequence. So I need to select based on the last direction, actually one of these records. So let's get the last direction. So in case if you forgot where did we initiate, this one is basically at here on acceleration changed. So they actually we calculate and set last direction. Okay, and here let's select a specific anim override. So if the last direction is forward, we can simply get the start forward, and if this one is left, we can get the L90, and if it is right, we can get the R90. This backward is the one we need to figure out properly, because we have L180 and R180. So it will be selected based on the last velocity direction. If you forgot where did we implement this one, it is at the on acceleration change itself as well. Okay, so we simply set the last velocity direction based on the past parameter from here. Right. So we can simply check whether it is a positive value or not. So if it is a positive value, then which means there was a previous rotation based to the right side, which means we can get the start forward phase R180. Otherwise, if it is a negative value or 0, then it's a L180 or left movement or left rotation. So it can be plugged to false like this. And then finally we can plug it to backward. Okay. So somewhat similar thing we have been done at get start anim as well. So here you can see at here it's somewhat similar thing, right? Okay. So coming back to a start anim override function. After these selections, we can return whatever the anim override that we have been selected. And then I can plug this to here. Right. And if this is not forward facing, which means if you are strafing, then I can return a dead null reference like this for now. But later on, actually, I'm going to implement override movement for start pause as well. But for now, we can keep it as it is like this. Okay. Right. We can go back to where we left. So we were at anim graph, locomotion, start, and set up start state. So here maybe we can do some calculations at here. Yeah, so let's select anim start anim to be override using this function, and then we have to check whether we are sprinting or not. How to do that? Yeah, there is a boolean called is printing, and let's use select, and if we are sprinting, then we have to actually show the override for sprint pause, but otherwise we can return this one. So for now, let's keep this one is empty, and later on actually we can add this proper sprint anim override pause to here. Right. Then I can promote this to a variable. But what I've done at the get start and it's somewhat same. Yeah, for now let's promote this to a variable called anim override start pause cached. And I'll assign it to anim overrides category. And here let's plug these two pins like this. Yeah. and then we can select the anim sequence to be override. Okay. Plus, I think we have to do the same thing at update start state as well. Therefore, I'll copy this stuff and go to the update start state function. Maybe I'll add a sequence here, and I'll plug the second pin to here, and the first pin I will plug like this. Right. But this should happen only if the blend override weight is 0, because we are keep checking its update start state. So we can get this one from here. Let's break it and let's use its override weight, and this one is equal to 0 only if that's the case we can reinstantiate it, otherwise we can keep as it is. Right. Okay. Plus, do we have a variable called sprint change? Yeah, we have a variable called sprint change, which means actually whenever we started sprinting, we should reinstantiate this again. So I'll copy these 3 and go to my set animation data function, and inside anim overrides, let's add a sequence here. Or do I have other place? No, let's use here. So I'll plug the first pin to here, and as the second pin, first I have to check whether the sprint is changed or not. So if it is changed, if it is not changed, I have to instantiate it at the next frame, right? Okay. Right, and then finally we can go to our anim graph start state, and here here let's get that override start post cached, and let's break it. Right, now I have the references to be plugged here. So as the weight, let's add the override weight. As the interrupt speed, let's add the interrupt speed, blend time, and blend time. Now these two I don't need, so I will hide the unconnected pins. Okay. And then we can connect it to here. Compile and save. Right. So that's how we can plug the different anim instance, which is ABP layered blend, inside our parent animation instance, which is ABP locomotion. But it's still we have some stuff to do, because like you can see, currently the sequence evaluator is empty. So it is not actually pumping this anim sequence to this evaluator, because actually the anim sequence that exists inside this structure should pass through the sequence evaluator, and it should go to this layered blend. So once it passed to the layered blend, if it is weight is 1, it will select this blend post and pass it from here. But in order to do that, actually the sequence evaluator do that evaluation and return that blend pause pause to be blend from here. So I think we can cover it on the next part. Otherwise this section would be too much longer. Right. So we'll see how we can do those stuff in the next tutorial. I'll see you there. Thank you.